For Chapter 4, we're going to finish up with biomes. So biomes, if we look at this graph, climate and where they're located affects where those biomes are. So if we have annual precipitation and annual average temperature, we have our extremes. We have our tundra that's down here, which is low in precipitation, low on average temperature. We have our desert, which is also low on precipitation, but high in temperature. And then we have our rainforest, which is high in precipitation and high in temperature. These other biomes sort of puzzle in between here. We can sort of think, we know Boreal Forest, that's Canada, that's, colder, closer to the tundra. And then tropical seasonal forest, Savanna, in between that with deserts and rainforest, not quite as much rain as a rainforest, but not as dry as a desert. And we can sort of puzzle in these other biomes that are in there. We know that latitude affects biomes. So if we look at along the equator, we're not surprised to see along that intertropical convergence zone that that's where we're going to find our tropical rainforests. We're not surprised that up in the northern latitudes, we're going to see the tundra. And you can see how they are distributed along those different latitudes. You can see how the biomes sort of group themselves, and we can see definite patterns with how they're placed. So let's step through each of the biomes and go over a couple of the facts that we have about them. We'll start off with the tundra, and the tundra is our short and soggy summers, long, cold, dark winters. Think Alaska, think Russia, think Canada, think those northern areas. There's poorly developed soils, and one of the key things that we have there is permafrost. It's the only biome that has permafrost. It's found at high latitudes or high altitudes. If you think high up on a mountain, there's a short growing season, it's low productivity, it's a fragile biome. Climate change is highly impacting this biome because this is the bulk of where if we warm temperatures, we're going to start losing that permafrost, losing that snow, losing that ice, and that's going to drastically change what's going on there. Plants that we can think of, ground-hugging plants, mosses, lichens, short grasses, nothing big and substantial is going to get a chance to grow up there because of the short growing season. And we think of our snowy owl, our caribou, our Arctic fox. Those are all animals that we'll find up there. The Boreal Forest, now we're moving down. We're thinking of Canada. They are also long, cold winters, short, mild summers, a little more precipitation. This is our Maine and Minnesota, Russia, Canada, you can see on the map. It's nutrient-poor soils, and they're acidic because this is the bulk of what they have is coniferous trees, our pine trees. A few deciduous trees, but mostly our pine trees, and because when pine trees drop their needles, they cause the soil to be acidic. It's only in the northern hemisphere, so we don't have any boreal forest in the southern hemisphere. And then impact is mining, oil extraction, logging. Animals that we can find there, the gray wolf, the river otter, the grizzly bear, animals that we think of when we think of Canada. Temperate rainforest. This one is a little bit different for us to think about because temperate rainforest is not a tropical rainforest. It's important because it's a coastal biome, and that's a real important thing when we look here. So we think of Olympic National Park, we want to think of Oregon and Washington. So they're all coastal biomes. It is the fact that it's along the ocean that allows it to have more moderate temperatures and provide that water vapor. So if it wasn't along the coast, those temperatures would be more extreme. You can see where they're located latitude-wise. Our human impact are logging, mills, they're fisheries. It has rocky acidic soil and lots of spruce, fir, but also the redwoods, layers of mosses and ferns. We find cougars, elks, porcupines, and tree frogs in a temperate rainforest. Temperate seasonal forest, we should feel very comfortable with. This is us. This is where we live. So think New Jersey, think Vermont, think where we are. We know that we have cold and moderate winters. We know that we have warm summers. We have year-round precipitation. We have good fertile soils, rich in organic material because those deciduous leaves fall down to the ground. We have a long growing season, high productivity. Much of the land is used for agriculture, development, industry. We know our animals: white-tailed deer, bald eagles, coyotes, black bears. These are the things that we're going to find in a temperate seasonal forest. Also referred to as a deciduous forest, or temperate deciduous forest is other words that people use to describe this biome. Woodland, shrubland. So now we're looking at Southern California, parts of Nevada, Australia. Hot, dry summers, cool, moist winters, thin, nutrient-poor soils because the winter rains leach it. It's referred to as the chaparral, also a Mediterranean biome because that's where it's located. You can see a bulk of it is located around the Mediterranean Sea up in here. Woody evergreen shrubs, small leathery leaves, things that grow during the winter, die in the summer. Animals we find are bobcat, cactus wren, roadrunners. The biggest impact is human-ignited wildfires. There's lots of vineyards that we grow there. The wildfires is what is very destructive to that biome. Temperate grassland or cold desert. So here we're looking at Oklahoma, okay? Think the middle of our country, think Kansas, think South Dakota. There's other areas, obviously, a large area here that's also referred to as temperate grassland, but I'm trying to put in places that you have thought of. Warm, hot summers, cold winters, moderate seasonal precipitation, very fertile soil. We do lots of planting. Our human impact is agriculture because we want to grow things there. We also are fragmenting that habitat, hunting, poaching, and urbanizing those areas. We refer to them as prairies. It's dry and windy. There's fires, so there's not a lot of trees that grow there. They don't get established because of prairie fires. And the dominant plants are lush perennials, grasses and herbs. Most are resistant to drought and fire and cold. Our animals are our prairie dog, our badger, our vole, mink, the things that we'll find there. Tropical rainforest. This one we're pretty familiar with this idea because it's just something that we see in movies and videos a lot. It's celebrated. It's hot and wet year-round. We're looking at Brazil, Indonesia, Peru, Madagascar. Thin, nutrient-poor soils, which is ironic. We think there's all this biodiversity, so there should be really good soil there. And there's not because there's a quick uptake of nutrients. So as quickly as those nutrients are put in the soil, they're taken by all of this biodiversity that's growing there. The Intertropical Convergence Zone is real important. That's why we're getting all of that rain. It's along that equatorial line, so we have the heat and we have the rain. Dominant plants, large woody vines, orchids, bromeliads, climbing plants. That's where our chimpanzees and our toucans and sloths live. The human impact, deforestation, loss of habitat, loss of biodiversity. We're talking about the 6th mass extinction going on because we are taking out tropical rainforests and things with biodiversity faster than it can regenerate. Erosion, climate change is in fact impacting it. Loss of potential medicines. So we have to really make sure that we protect not only our whole earth, but our tropical rainforests especially. The tropical seasonal forest or the savanna. We want to think of Kenya. We want to think of those grazing animals. Think of Zimbabwe. Think of Tanzania. Warm temperatures, seasonal rainfall. So we opened up this chapter by talking about how Kenya had no rains for part of a couple years, and how impactful that was. The seasons are due to that intertropical convergence zone. That is a big part of their climate. Fertile soil is there. It's compacted by animals. The human impact is that we're converting this land to agriculture and grazing and hunting and poaching and mining and recreation and tourism. We have to be protective of those areas. This is where we're going to find the African elephant, the zebra, the mongoose, the baboon, our African savanna animals that we think of. Tall grasses and some drought-resistant and fire-resistant trees or shrubs, that acacia tree, that typical Kenyan tree that we see pictures of. Subtropical desert, now we're talking about Arizona, Egypt, Mexico. Low precipitation, variable temperature. The key features of the soils are rich in minerals, but poor in organic material. So there's not a lot of organic things going on there, even though there's a lot of minerals. This is where our cacti and other succulents live. There's low diversity, low resistance and resilience, and very low productivity due to that low precipitation and also low organic material. The human impact, we're using ATVs, military exercises, drilling for oil. This is where we're going to find our jackrabbit, kangaroo rat, armadillo. And now we're going to take a look at aquatic ecosystems. So aquatic biomes are categorized by salinity, depth, and water flow. So this is how we're going to figure out which one they are. Salinity, the amount of salt dissolved in the water. Temperature is still important, but we really categorize our aquatic biomes as freshwater or marine. So let's take a look at the freshwater ecosystems first. Streams and rivers, they have flowing fresh water. They originate from underground springs. Creeks are narrower. Rivers are wider. Water flow affects the biological communities that they pass through. Rapids are stretches of turbulent water in streams and rivers. Beautiful picture of a stream, much like the one that we researched earlier this year. Lakes and ponds. Lakes are larger than ponds. There's no clear point. There's no like, this is a lake, and if you get to this big, now you are a pond, or this small is a pond, and this large is a lake. They can be used sort of interchangeably, although we refer to lakes as larger bodies of water. And it has 4 distinct zones. That littoral zone, the limnetic zone, the profundal zone, and the benthic zone. If we take a look at this diagram here, profundal zone, this is dark, the bottom, light cannot get to it. That's the key part there. Benthic is anything touching the bottom. Littoral zone, this is what's touching along the edge. And the limnetic zone is the open water that light can penetrate down towards. You want to know those 4 different terms and what those zones represent. Freshwater wetlands. These are aquatic biomes that are submerged or saturated by water for at least part of each year. Shallow enough to support emergent vegetation, swamps, marshes, bogs. We differentiated all of those in our aquatic ecosystems biome book, but they are very similar. They're very productive biomes. They provide several critical ecosystem services. So we differentiated them, but they're very, very close. I mean, we're thinking of the Everglades and bogs in Ireland, things like that. And here are some pictures of some freshwater wetlands. Marine ecosystems. Salt marshes are found along the coast in temperate climates. They contain non-woody emergent vegetation, and it's one of the most productive biomes in the world. Mangrove swamps are found along tropical and subtropical coasts. They contain trees. Those roots are submerged in the water, so they are more specific. This is where we find our snowy egret. This is the Gulf of Mexico coast, tropical coastlines, this brackish water that's there. The intertidal zone. Intertidal zone is that narrow band of coastline that exists between the levels of high tide and low tide. This is essentially the beach that you go to or the rocky shore that you go to. And these are where we find our starfish and anemones and barnacles and sponges and seagulls live there. Anywhere ocean water touches land. At high tide, it's a more stable environment. Low tides, it's a harsh environment. Waves crash onto the shore. It takes a special type of organism to live in that kind of biome. Things that we're doing to it is developing those areas because we want to live along the coast as well, and then tourism and pollution. Coral reefs are found in warm, shallow waters beyond the shoreline. Coral's tiny animals that secrete a layer of limestone, which is calcium carbonate, to form an external skeleton. Earth's most diverse marine biome, but the water is relatively poor in nutrients and food. And we've talked about coral bleaching, especially as a result of El Nino years with that movement of warm water. And here's some pictures of a coral reef and then some coral bleaching due to unusually warm waters. The open ocean past that intertidal zone, so going out into the deep ocean, the depth that light can penetrate in the ocean is dependent on the amount of sediment and algae suspended in the water. So what's in the water will determine how far that light can go down. The zones that we have there, the photic zone, that's the zone that receives enough light. And then we have the aphotic zone. Deeper water, There's not enough light for photosynthesis. Things that live there can do chemiosynthesis or bioluminescence. And then the benthic zone, which is the ocean floor.